So now that we've taken a look at multiplicity, we can kind of put together all these pieces about polynomials. We've gone through one of these examples together, and now if you want to, I want to just kind of guide you through these second two examples. Remember that these are the same as on the student note sheet, so I really encourage you to be writing these down so that you can come back and look at them as you need to kind of review what we talked about. So what our goal is to find all of the real or complex roots. Now the real roots we can find either by factoring, looking at a graph, or we could use the quadratic. However, to use the quadratic, it has to be x squared. And so in this situation, when we have an x to the fourth, that's not an option yet. But we can always start by finding these zeros looking at our graph. So when we look here at the graph that's provided, we see two zeros. We see a zero at -2, and we also see one at a +2. Now remember, if you're not given a graph, go ahead and plug this equation into Desmos or into your graphing calculator and look at it. Find where those zeros are. The real zeros will always be where your graph crosses that x-axis. Now what we want to do is we want to kind of take this factor out using division, maybe synthetic division, long division, PolyDoku, whatever process of division you want to use. Go ahead and factor it out of here. And so that's where we're going to start, but we have to just take one out at a time. So what I want to do is I'm going to set mine up as synthetic division. It says synthetic division here, but absolutely use whatever division method you're most comfortable with. And so I'm going to start by taking out that -2. Now remember, in synthetic division, we put that 0 in that little corner, and then we're going to write our coefficients. Notice that there is no x cubed, so I need to put a 0 in its place. There also is no single x, and so I'll put that 0 in. Okay, and now as I run through synthetic division, remember that I add down and multiply it by 2. So 1 times -2 is -2. Then I add straight down, and I'll get another -2. I multiply it by this -2, which will give us 4. I add straight down, and I multiply it by -2. I add straight down, and I multiply it by that -2. Now, I know that I should end up with no remainder because I know that this is a factor. And so what this means is that when I factored out x minus 2, I ended up with x cubed minus 2x squared plus x minus 2. And so now I can write it in that factored form instead of how we started. They're equal to each other. They're just written in different forms. Okay, now I want to factor out another 0. I know that I can also take out this 2, right? We found both of those real zeros. So let's go ahead and factor out the next one. Now, when I set up synthetic division on this one, I want to factor it out of that part I just found, right? This is where I want to take that factor out of. Make sure you're taking it from here, not from our original. So we want to set up our coefficients. 1, -2, 1, -2, and I'm going to do synthetic division again. Bring that 1 straight down and multiply it by 2. Add down and multiply it by 2. Add down and multiply it by 2. And add down. Again, I should see that 0 there because I know that it's a factor. There should not be any remainder. And what this means is instead of how we had originally written this, instead of this equation here, we really have factored it and said we could write it with that factor of 2, our factor of -2, and we're left with x squared plus 1. Now at this point, there are no more real zeros, and so we want to take that and move into how we might find the real zeros. I'm going to transfer this equation to my next page here. Remember that we had x minus 2, x plus 2, x squared plus 1. These parts are already factored. We found the zeros. Now the problem is that we need to find the factored form of this right here. It cannot factor, so we're going to use that quadratic and find our complex roots. So for a moment, we're just going to focus in on this part right here. So the opposite of b, there is no b, plus or minus the square root of b squared minus 4 times a is 1 here, times c, which is also 1, all over 2a. So as we start to simplify this, notice where our complex roots are going to come from. Instead of writing the square root of a negative 4, we're going to write 2i divided by 2, which is the same as plus or minus I, right? If this is a little unfamiliar to you, I encourage you to go back and re-watch that lesson on imaginary or complex numbers. Okay, but what we have just found is we just found our other zeros. So we have a 0 of 2 and negative 2. We found those by looking at our graph and then by dividing those out. And then we found that we had an imaginary root of I and even one of negative I. Now I want you to think back to our degree here, right? Remember that our degree in our original equation was x to the 4th. And we have 4 zeros. Make sure that you found the zeros that kind of match up to that degree. If they all have a multiplicity of 1, that means they're all used just one time. We should have that many zeros. Okay, let's look at one more example. Now again, remember we're going to start by looking at our graph and finding that real root. In this situation, we have a real root of 3. So I'm going to use division to divide that out. This time I'm going to use some long division. So we have x minus 3. And we're going to divide that by our original equation, which is 2x cubed minus 8x squared plus 9x minus 9. Okay, so let's start to divide that. We ask x times what is 2x cubed? Well, that's 2x squared. 2x squared times a negative 3, which would be negative 6x squared. And now, just like in long division, we then subtract those. So we'll have a negative 2x squared, bring that part down, plus 9x. X times what will give us negative 2x squared? Well, that's a negative 2x. Again, we're going to subtract those. So we're going to end up with 3x minus 9. X times 3 give us 3x minus 9. Remember that we know we want to get that remainder of 0 because we know this is a root, right? We see it in the graph that it's a root. And so what we can do is we can kind of rewrite these two things are going to equal exactly the same. We've just factored one. So one will be x minus 3 times 2x squared minus 2x plus 3. Those are the same equations. One is just factored. So now that we have that, I'm going to transfer that into this part here. It was x minus 3, 2x squared minus 2x plus 3. And so now we need to continue to factor this part in order to find those complex roots. So let's plug it into our quadratic formula. The opposite of b plus or minus the square root of b squared minus 4 times 2, which is 8, times 3, which is 24, all over 2 times a. Let's see what that gives us. Now remember, we don't want to just plug this into a calculator. We want to simplify that root. If I look at this square root of 20, this is the same as saying 4 times 5. We can break down that root. So instead of square root of 20, we could rewrite this as 2 times 2 times 5. Remember, we take any doubles out. This will be our simplified radical. So we'll have 2 plus or minus 2i times the square root of 5 all over 2. Now it has to be always written in a plus or minus bi form. So we have to make sure to divide that both places. So our zeros here are 1 plus or minus I times the square root of 5. We also had a 0 of 3. So here are all of our zeros, our real zeros and our complex zeros.